Is light a wave or a particle? In the 18th century, Isaac Newton came up with his corpuscular theory of light, which stated that light is made of tiny particles called corpuscles that always travel in a straight line. However, in the 19th century, Thomas Young used his double-slit experiment to show that light actually behaved like a wave. By observing other properties of light, it became clearer and clearer that the wave model was the correct model. So it's settled then. Light must be a wave. Well, not so fast. In 1921, Albert Einstein won a Nobel Prize for his explanation of the photoelectric effect, which proved that light was acting like a particle. Let me show you how this is possible using the gold leaf electroscope. So I'm going to charge the zinc plate negatively, which makes the gold leaf repel from the central bar. Firstly, if I shine visible light on the zinc plate, nothing happens, no matter how intense my light is or how long I leave it there. However, if I shine UV light, the plate gradually loses its negative charge as the electrons are released from the zinc atoms. This leads to the gold leaf no longer being repelled. So how does the photoelectric effect show that light behaves like a particle? Well, electrons exist in energy levels, so we can think of electrons on the surface of the zinc plate existing in an energy well. So a specific amount of energy is required to remove the electron from this energy well. If light was simply a wave, we would see that it would continuously transfer energy to the electron and eventually causing it to be released. So this would happen with all wavelengths of light, even though it would take longer for the longer wavelengths of light to do this. But as you have seen, this is not the case. No matter how high the intensity of visible light is, the gold leaf stays repelled. Whereas the particles of UV light have enough energy to remove electrons, making the gold leaf no longer repelled. This observation can only be explained by the particle nature of light. We call this particle of light a photon, and the photon energy depends on its frequency. So, the higher the frequency of light, the more energy its photon has. And a single photon interacts with a single electron, giving away all of its energy to help remove the electron from the atom. So, is light a wave or a particle? Well, it's both.